afternoon, good evening, good morning to everybody wherever you are. Today we are continuing with our lessons on Docker, and we'll be looking at environment variables. I think we did environment variables in our last session. Yeah, we already did environment variables. We installed MySQL, if I'm not forgotten. We installed MySQL, and we actually exec into the MySQL container and exec into the database. And we talked a lot about database in our last session. We said what databases are all about. We also talked a lot about web servers. We talked about what web servers are. So today we are going to be learning something new. We are going to be learning something very new: creating multi-container architecture in Docker. We'll be creating multi-container architecture in Docker, and we are going to be using the first CRUD method called --link. Okay, we are going to be using --link, and then we will learn how to use that --link to create a LAMP architecture. We're going to create a LAMP architecture in Docker, and then if time permits, we are going to see how we can create a CI/CD environment in Docker. Okay, and then creating a test environment using Docker. What is a test environment? We are going to look at that. I'm sure we are going to look at this too tomorrow. Creating test environment and using and installing Docker Compose. You will see what Docker Compose is. Docker Compose and --link, what they are all about and what they do. Okay, so in real term, I have my demonstration board. Okay, in real term, we said Docker is a collection of containers. Everything you are installing is a container. Anything you are installing is a container, right? You have installed Nginx container. You have installed Tomcat container. Some of you have even installed MySQL container. This is what you have been installing. You've installed a Nginx container. You've installed a Tomcat container. You've installed a MySQL container. These are all containers. Question is, what does Nginx do? You have really installed a Nginx container. You are happy that you have installed a Nginx container. You tested it. Yes, it's working. Fine, that's good. Clap for yourself. Now, question: what does Nginx do? What is the use of Nginx? Right? The use of Nginx is that Nginx is a web server. Nginx is a web server. So, if Nginx is a web server, then Nginx needs to attach itself to a database, because Nginx is a web server. Nginx does not keep data. Nginx is just simply a web server. It doesn't keep data. This is Nginx. It is a web server. It doesn't keep data. So, in the case of Docker now, how will you use Nginx and a database? This is now a MySQL database, right? This is my MySQL database. And what is this? This is a database. MySQL container is a database. Nginx is a web server, right? So these two things need to communicate. So in Docker, you have what we call --link. In --link, what we do is we install the database. Always begin from the database. We install the database first, and then we create Nginx second, and then we establish a link in between Nginx and the database. This link like this. We are going to establish a link in between Nginx and a database, and we are going to name the link. Okay, so in this way now you have what type of an architecture? You have a web server. You have a web server, and that web server is going to be Nginx. That web server is what the internet people are going to be looking at. And then this web server, if it is a web server that accepts data and accepts information that can be stored, the web server is going to take the information and then using this hyphen link, send the information to the database. So this database is going to be configured in such a way that it is going to be receiving information from your application. In between this database and this web server is an application, right? An application that is running here, because inside your Nginx there is this application. This Nginx is just a web server that takes information from the user, pass it to the application. Then the application is what has been configured in this database. The database has been configured to receive data from this application. So we are going to create now a situation in which you are going to be constructing. This is what we'll call it. You are going to be constructing an architecture. What type of an architecture? Using Docker, you are going to be constructing the architecture of a web server, architecture of a database, and architecture of an application server. Okay, when you create these three architectures, then you link them together. This is a combination of what is called microservices. Microservices, or we call it microservice deployment. Now, at the beginning, why am I insisting here? Because huge companies are making a lot of money converting applications from monolithic to microservice deployment. Let's talk about this for a moment. What is a monolithic application? I doubt whether there is an application in Cameroon now that has been deployed using microservices. I doubt. I am to be corrected. I doubt. But I've seen a lot of guys doing DevOps, but I doubt whether there is any structure that has actually welcomed the deployment of microservices. But that is the deployment that is working today. That's the deployment that functions today. Because in general, what used to happen is that you, Roberto, you sit down somewhere in your house, you write an application that is a full application from start to end, top to bottom, full-fledged application. When you write that application, what do? You take the application and then you deploy a full-fledged application of this nature. You deploy the application. And where do you deploy the application? You deploy the application into a particular server, right? When you deploy the application into that particular server, in this application, everything is involved inside. There is a database inside the application, right? There is a web server inside the application. Everything is entangled inside this particular. You mix up everything and you entangle it all together and you deploy. All this runs inside one particular server. Inside a particular server. This is called a monolithic. Everything is one, holistic. This is monolithic. Okay? So, what is the problem with monolithic? The problem with monolithic is that monolithic deployment. The problem with monolithic is that the least crash on any side, the whole application is stopped. It is down. There is no way you can do everything. Anything that happens anywhere, the application is down. That deployment is totally blocked. Everything is halted. That is the problem with the monolithic deployment. All right. But with the microservice deployment, this containers can be deployed in different servers altogether. This database can be in Germany, the application can be in Cameroon, and the web server can be anywhere. You can deploy them anywhere and interconnect them, link them together. Okay, you can deploy them all over and then you link them together. That is microservice. So if the problem is coming from your database container, there's a way by which you can isolate your database container, provide another database. Maybe you had a backup database, you provide the database, the secondary database, and you are arranging this particular database that is having a problem. After you restore it and you restore everything, if a problem is having at the level of your front end, you can provide another container to save the situation while you fix this other front end after you restore everything. So that is how microservices are functioning. Okay, and the whole sense of deployment today is deploying using microservices. So we are going to look at how to interconnect containers. That is the first thing we are going to do today, looking at how to interconnect containers. All right, what do I have here? Okay, I have Tomcat. Okay, let me see what containers I am having. Okay, I want to delete my this Tomcat container. So you are certainly seeing two other containers that are running. Don't worry about these two other containers. They are running in my Kubernetes cluster. And when you come to Kubernetes, you understand what they are and how to set it up. I'm pretty sure that it will be another daunting task, just like installing Docker. Some of us had to go extra miles to do the installation. I'm very certain that Kubernetes will be the same. So just hold on while my container is being deleted. Let's come to my lesson notes. The first thing we are going to do here is okay. This is what we have. Multi-container architecture using Docker. Okay, and we say that this can be done in two ways. We have the first way is --link, and the second way is Docker Compose. Docker Compose is another extra feature in Docker that we are going to install. So today we are going to be looking at --link. I'm certain my system must have deleted, not still yet. So the containers that we are going to be linking, I want to use as many different containers as possible so that you should be having an idea of different types of containers. We'll have a container called BusyBox. So we are going to start two of them, right? And then we create a link in between them. So in the first way, we are going to run this command: docker run --name C10 IT BusyBox. Who can explain to me the full context of this command and what it does? Yes, Roberto, your hand was up first.
Okay, so this command Docker run is to run a container, in fact an image, but that will become a container anyway, called BusyBox, and with the name C10, then minus IT surely I think it's to enter the container. I'm not very sure, but anyway, I think it's to enter the container once we have run into it.
Exactly. That means you are saying that Docker run is we are trying to say that we are going to run this container directly from Docker Hub, right? We are not downloading it because we have not downloaded any container. And also, we are running the container directly from Docker Hub. We did not use a Docker pool. We have not used Docker pool, but we are talking about BusyBox. So we are just going to run the container directly from Docker Hub. And when we run the container directly from Docker Hub, what will happen? The Docker will tell us that I am not able to see this container locally, so I am going to search for it in Docker Hub, and then it will go and search for it in Docker Hub. The name of the container is C10. We just give simple names for rapidity. The name of the container is C10. So we run the container, we run the command. You see it very clearly. Unable to find image BusyBox latest locally. So when you are unable to find it locally, you have to go and pull it if it is necessary. Technically, it is now pulling it. So as you did say, we are expected to enter the interactive terminal of BusyBox. We are expected to enter that interactive terminal. Enter inside BusyBox. Okay, we are expected to enter inside BusyBox. So when our container will finish, we will see a different terminal that is different from our normal terminal that we usually use. A different terminal should come up that shows that we have entered inside the BusyBox container, if everything moves well. So they are saying that our status is downloaded, newer image for BusyBox latest, and it is being installed now. Now while we wait for it to get installed, when it will get installed, we will enter inside the container. Now if we are inside the container, we need to come out from the container to create the second container. I hope you get these ideas very well. We are inside this container. We are inside a container. We have just created a container and we entered the container. We are inside this container. We are supposed to be creating containers in Docker. So we created a container and we entered inside the container, and this is where we are located. We are located here. If we want to run commands here, then we are going to be running commands but inside this container. So we have to exit from this container and come back here and create another container. Now if you just click exit, this container will exit and shut down. That means if you just run exit like we used to do, the container will exit and it will shut down immediately. So in order not to make the container exit and shut down, that is why we are going to be using the combined commands. You are going to press Control P-Cure, right? Control P-Cure to exit the container but without shutting the container. Okay, you see now where we are. This is a different interactive terminal. Okay, we are now inside the BusyBox container. The container created, and we are now inside the BusyBox container. Inside this BusyBox container, we can run things. We can like say apt update. So let us exit the container and create the second container. You press Ctrl P cure, and then you exit the container and come back to your normal terminal. Now this container is created, this terminal is there. Don't worry, we'll come back to how to update that container. Now in the second command, what are we going to be doing? In the second command, we are going to be creating another busy box. At the same time we are creating another busy box, we are going to be linking that busy box with the first busy box that we created. Take a look at the command, please. Take a good look at that command. This is the command that we are going to be creating. This command says docker run --name. The name this time is C20, right? C20 --, link. Now this is something we have seen today. This is something new. We have creating now the second container C20. Now we are saying --, link. We are asking now Docker to link our C20 to our C10. So we are going to link C20 to C10, right? And then hyphen this here is the link name. This is the link name. We are going to also enter the interactive mode and then the image name. So let me break it down again. This one is the command docker run, we all know it. This one is the --, to pass the name, we all know it. Then this second one is now the link. The link ends here, please. You take the link from here, --, link, and then you end it here. So --, link, you are linking to C10. --, link, you are linking to C10. And then you are giving the name of that your link. This is the name of your link. So to tell the new container that I have a link, that link is called C10 alias. Okay, this one is the name of that link. And then you are going to enter the interactive terminal, and then you are going to use the image busy box. Okay, that is the explanation of that command. So let us try to see how we can run this command. So what are we expecting? We are expecting the container to run, and then we enter inside the container. Okay, right now we are inside the container. Okay, we are inside the container. How do we know that truly this container got linked into our first container? That is a question that we should always have in our minds. How do we know that yes, we wanted to link C10 to C20? Did it work? Did it actually work? We are going to ping C10. We are in C20, right? So we are going to try and ping C10. This is how we ping C10. You just run ping and then C10. If we ping C10 and it goes through, then we are connected. If it doesn't go through, then C10 was terminated. You see, we have ping C10. You see how it is pinging. It will continue to ping like this forever, right? That means there is constant traffic that is flowing in between C20 and C10. Okay, have to stop it. Control C, you will stop it. Okay, so when you ping, it will constantly be telling you that yes, there is a traffic that is fluctuating in between C10 and C20. That is, there is a communication link between them. So that is the first aspect of connecting. That is how you can connect containers together. Okay, and remember, we want to quit without closing the container. We press Ctrl P cure, right? you leave without stopping the container. So if you press now docker container ls, what are you going to see? You are going to see C10, you are going to see C20, right? This is the C20 that we just created, that is its ID, and then this is the C20 that we created, that is its own ID. This is its own ID. Okay, so that is how. Let us increase this thing to show you, so that you should not get confused between the nomenclature, because these names came here and it was like confusing. So you see now that this is C20 up and this is C10 down. Okay, so in real essence now, we have created two containers and we have linked them together. That was our task. It has been achieved. Okay, creating two containers and linking them together. The second thing that we are going to do today is to create now a full-fledged complete structure that is generally used in all applications. That is, we are going to create a database and we are going to link that database to a WordPress service. It is like this very architecture, right? Let's create now a MySQL database, and then we are going to take that MySQL database and link it to a WordPress website. We are going to create a database and then we link that database to a WordPress website. Okay, with the idea of hyphen link, you can already do that type of an activity. Okay, so let us see how that can be done. Come to my notes here. All right, we always remember that you begin creating your architecture from the base. Okay, you create your architecture from the base. Architectures must be created from the base, and the base starts from where? Database. Your base begins from database. After database, you have application server. After application server, then you have web server. That is how it functions. Database, application server, and web server. That is how it is supposed to function. Before we do that, let me terminate the applications that we have, the containers that we have. We have BusyBox U, and then we have BusyBox U. I can terminate the two applications at the same time. How we know why I am putting -F? I am forcing the termination because the containers are running. The normal principle is you stop the container before you terminate the container, right? Before you delete the container. But I'm deleting a container while running, that's why I'm passing -F. Okay, right now container docker container ls. So I can see those two containers are off. Only my normal containers are present there now. Okay, now we want to install our password. We did study something about environmental variables yesterday, right? If we want to install our database, the first thing you should do is, what is the database? The database is my SQL database. The version is 5, right? That is the version of the database that we want to install. Inside a database, what happened? There are environmental variables. We did say we must pass an environmental variables, and the environmental variables that we are going to be passing here is, we are going to be passing a password. We are going to be passing a password. So the name of that container will be mydb. So the difference in this particular command is the environmental variable that you are going to pass. I remember one interview that I failed that they asked me, how are you going to pass a container that contains environmental variables? I was unable to actually write a Docker Compose file and add an environmental variable to it. So you should be very careful. These are things that are always very much sensitive when they are doing interview. So this is the command that we have. We already know the command. Question: why don't we have hyphen link in this command? We cannot have hyphen link in the first command. The first thing is that you first of all have to create the first container. Then when creating the second container, before you link your second container to the first container, like somebody has to be created first before another one. When being created, they link now, not like you are going to create the first one and then you start linking to what, linking to where you don't yet have the second container. So the first container is just going to be created. Okay, the password to that container is my name. That is the password. Okay, so we go to our service. While it is pulling, let's take a look at our WordPress here is our WordPress website. This is the container for our WordPress website. Okay, that is the command. Docker run hyphen name, we already know this. My site, that is the name for the container. -d, we want this container to run in detached mode. -p, we know this, right? -p, we are doing a port binding here. Why did we do a port binding here and not in the second one, in the first one? Please, can somebody answer this question? Why did we do port binding? Why are we doing port binding here, but meanwhile in this one we did not have any port binding? Any answer to that? Yes, Mr. Edin.
Yes, I think we are doing port binding at the second one because we are going to be inputting our data, but here in the WordPress.
What is port binding? First of all, you are talking about port, you are talking about data. What is port binding? What is the aim of port binding? That's where you have to start from. What is the essence of port binding?
So I think the essence is to be able to have access to your how can I put it, container, to be able to connect to maybe your container to your client to your desktop, so have access to it from the website. I think so.
And why did we not do it in the first command?
I'm just joining, so I was not when it was taking place.
Okay, and you are struggling to answer. When we talk about port binding, please. When we talk about port binding, yes, Roberto.
Yes, I just want to, let me just try. I think we did not do it in the first command because the first command, the first container will take, I think the two containers are going to use the same port. So if the first container used that port already, the second one should change the port so that they don't mix or confuse.
So that they don't mix or confuse. Okay, now look at what we are trying to do. Always visualize this thing in some sort of a diagrammatical function. Look at what we are trying to do. There is a website, there is a database that we have created. This is what I'm asking. There is a database that we have created. When we were creating this database, there is a container, and inside that container is a database, right? And inside this database, we pass the environment variables like the database name and password that we can have access to. And in this container, we never created a port. We never created a port. And in this container now that we are creating, we have created a port. Question: why are we creating port binding here and we did not create port binding here? That is the question. If you understand it from here, then you understand. And then you do understand that what is port? What are ports used for? What are ports used for? Yes, Roberto.
So we don't create port. We don't do port binding in the database because it is the container of the application that will access database.
Exactly.
So we are going to be accessing that particular container through the internet. That's what we have to do.
Exactly. You do not open your container containing your database to the internet. It does not work. You do not open your container that contains your database to the internet. That means somebody anywhere can have access to your container. Is that what you are trying to do? No. So you do not give your containers any port. Your containers are not supposed to be having any port. The containers that contain database are not supposed to have any port. They are connected via a hyphen link to this one, right? For any person to have access to this person, he must be connected by the application, and the application is connected to this one via a hyphen link. So why will you pass now a port here? You are going to pass a port here because we are going to be accessing our website from our web application, from our laptops, from outside, from anywhere. We are going to have access to our website like this. We have to have access to this website. That's why you are giving it a port. That's why you are mapping it with a port, because we need to have access to it. And when we have access to it, now it is this hyphen link that we created that will have access to our database. So please have the ideologies in your mind, have the architecture in your head, and know the reason why you are doing this. Because if you just cram it and do it and it works, they will ask you a question that you have done and it works, but they will ask you to explain what you did and you will not be able to explain. So always have this architecture in your brain and always know why you are doing this. So we are giving this one now a port because this one is a web server. Databases don't give a port because they are databases and supposed to be isolated from the internet. When we will go further, when we will start doing services and go further to Kubernetes, you will discover that there are special type of ports that are given to databases. There are very special type of ports that are given to databases, and those ports can only be communicated within the architecture itself and not from outside. We will see that when we reach there. Okay, but this idea of you having the notion that ports are not supposed to be given to database containers. All right. Immediately after we finish, we take localhost and then we put in our browser and then we test, and that's it. We are going to do the LAMP architecture probably tomorrow, where we are going to, let me just talk about the LAMP architecture so that you can try it yourself. I might send you these notes so that you yourself, I think I should give the LAMP architecture as an assignment. Yes. The LAMP architecture is going to be an assignment that we are going to check tomorrow. So what is a LAMP architecture? LAMP stands for, L stands for Linux, A stands for Apache, M stands for MySQL, and P stands for PHP. What is Linux? Linux is an operating system. So a LAMP, when they talk about LAMP architecture, they are talking about an architecture built in a particular way that uses particular technologies. The LAMP architecture must be built on a Linux operating system. It's an architecture that is built on a Linux operating system. It is using an Apache web server. That LAMP architecture should be using an Apache web server. It is using a MySQL database. It is using a MySQL database, and the application that has been built with that architecture is built with the language PHP. Right? It is built with the language PHP. So this is what we call a LAMP architecture. You already have Linux installed as a kernel in your WLS, and then from there you are going to install Tomcat. No, you are not going to install Tomcat. You are going to start by installing your database. When you finish installing your database, you are going to install Tomcat, linking Tomcat to your database, and then next, this is where I need to see now your assignment. Next, you are going to install PHP. While installing PHP, you are going to link PHP with MySQL, and then also link PHP with Apache Tomcat. So the first thing you are going to do is create MySQL. When you finish creating MySQL, you are going to create Apache Tomcat. While creating Apache Tomcat, you link it to MySQL. After when you finish creating Apache Tomcat and link to MySQL, you create now PHP. When you create PHP, you are going to link PHP to Apache Tomcat and MySQL. So the image for PHP is PHP. What you need to know is what port is PHP running on. You can go and find out. That is still an assignment. Search it. Find out which port does PHP run, because you will need to know which port you are mapping. Okay, which port does PHP runs on? So find out, does it need even a port? That is another question. Does PHP even need a port? What is PHP? Does it need a port? You are going to do that and find out and create this LAMP architecture. That is your assignment. Okay. All right, guys. I don't think we are going to wait for my system to finish. In as much as I have other things to do, I suppose you two guys have other things to do. So let us complete when it will complete, it will be the same thing. So you guys will just complete the assignment, the exercise, and then you do the assignment and you master it more better. All right.
Okay, sir.
Yeah, so that we should not waste our times waiting. All our times are useful and important. Okay. So see you guys tomorrow.